All right, when we last left the video series, we had created a 1D synthetic based on our well log. We had identified the hydrocarbon zones. And whenever I look on the main screen, hydrocarbon zone indicators are shown on the right. And these are gas zones, I've got a wet zone up there that we've identified for this well log. But we created our 1D synthetic, and now we wanted to start doing some AVO modeling. So we're going to create an AVO synthetic. So we go up to the synthetics. We had our 1D model that we created. And we can do AVO in situ or AVO fluid sub. So we can look at what this well log would produce, which is our in situ model, or we could look at two models side by side. One would be the in situ, and one would be a little more interactive fluid sub. Right now we're going to start with the in situ. And when I click on that, it pops up and says you do not have any data specified for the shear wave. We need a shear wave in order to compute an AVO synthetic. And if I look at my LAS file here, I have no shear sonic. How am I going to do this? I'm going to go back to the custom curves, which we should be familiar with now, and I'll right mouse on that and hit add custom curves. Now remember, we can always go to the top, the menu curve, add custom curve as well. What parameter do I want to create? I want to create an S wave, shear wave. I pick that from my list. And I notice that I have various methods. One is if you had a VP over VS, you could obviously compute the shear wave. If I had a shear sonic, I could do that. Or I can use a Greenberg-Castagna approach to estimate because we do not have a shear wave. And I click on that, and it tells me that in order to produce a shear wave with this technique, the formulas require a P wave, which we have, a shale volume, which we have, and a bulk density, which we have. So now I could do that and create a shear wave. Now the other thing that I want to make sure we're very clear on, because I've identified these gas zones right here, the way the software works to create these shear waves is it will fluid substitute, this does all behind the scenes, and calculate that shear wave using this technique for a wet case and then forward substitute to get it for the actual gas case. So we know that information is correct all along. Now when I hit OK, I have, lo and behold, a S-wave node here, and I'm going to right mouse on that and hit show curve. And again, remember there are many ways to show it. And I have my shear wave that's now computed over here. I'm going to go to view chart layout, and I want my shear wave to be right next to my bulk density. I want to take rid of the resistivity gamma, so I'm dealing with fewer curves than what I might normally have. So now I have P wave, bulk density, shear wave. Now you'll notice whenever we create these curves in parentheses around the actual parameter, that kind of tells you where it came from. And maybe it came directly from the mnemonic in the well log file, as is shown here for the bulk density, or maybe it was computed with some other technique, in this case Greenberg-Castagna. So I now have my shear wave curve, and again, that was calculated based on P wave density and shale volume. Now let's make sure we understand one other point. If we go and edit any one of those curves, let's say I go back and change my shale volume estimation that I used based off of the gamma curve, the shear wave will update automatically. If I change this hydrocarbon zone to a wet zone or change its default water saturation, it will update the computed shear wave. So all of these things are taken care of by the software, so you don't have to worry about making sure those things are updated. So now I have my P wave density shear wave, and I'm going to get ready to go create an AVO synthetic. So I'm going to create an in situ model to begin with, and I hit synthetics AVO in situ model. And I'm going to resize this window so that it fits nicely in our video screen. And like before, we have a set of well log curves that are shown here. We can change these we like. And we have an AVO synthetic right here. Now we've not provided any time scale information or whatever. The other thing I'll notice is we have the ability to show cross plots at the bottom, and I can drag that up. And we'll get into this. And we are going to do a few things first to get our view looking just right. When I'm over the well log chart or the synthetic, the mouse wheel scrolls down just like before, and they scroll in tandem. And you can see as I get down towards the bottom, or I can use the zoom controls at the top and I can zoom out, zoom in. Okay, or I can click and drag and zoom as well. Now, let's look at a few things first. I don't want to look at these cross plots because we're not going to get into that too much right here. We'll come back and look at those later. So I just go to View, and I would turn Layer cross plots and Boundary cross plots. I turn them off, and we can turn them back on because right now we're going to focus on this AVO model. So we have our well logs, and these curves can be whatever we like. And over here is our In-Situ synthetic. Now the time scale is shown, and we can click on. All we have to do is click on the time scale, and it gives us the initial time, final time. I'm going to go 2.2 to 2.9, and I'll put a time step at 0.05 decimal places. I could show it in seconds or milliseconds. Let's do it at 2 decimal places. So now I have my time showing quite nicely. And now the traces we have, this one at 0 degree offset, this is our offset as we go up. This was the same thing we had in the 1D synthetic. But then I have a new synthetic to look at all these at the offset variation. Now the one thing I'll look at across the top, I've got an AVO display control. So what are my wiggles? I'm showing the wiggles and they're in black. I'm filling the peaks and they're black. I'm not filling the troughs, and we'll leave it at that for now. And I can change the trace gain of the wiggles. And if I click this, you'll see that increases to whatever desired effect I like. Now we also have the ability to color the background. So I can do it a grayscale, or I can do a color scale. I'll do a color scale, and let me turn the wiggles off just so that we can see this. And I'll adjust the trace gain on that. I'll turn the wiggles back on but not fill the peaks. Now we have the trace gain of the color. So those trace gains are independent. And if we want to change the color scheme, there's a little palette button right next to here, and I click on this, and this is how we can change a palette. And I'll add a new color at 0%. I can slide these back and forth. I think we have a video that talks extensively on how to do these color palettes. But now I have a color palette applied to this AVO model. One other thing with the displays, we're showing this offset as a function of feet. We can do that in meters or feet, whatever we desire. But we can also hit show angle lines, and it computes the angles. And when I click on that, I've got it at every 10-degree increments. And again, these are settings that we can change. The wavelet that was used to create this is a 40 hertz wavelet. If I want to change that, I click on the wavelet icon, and I can go back to my 25 hertz wavelet, and you'll see the AVO synthetic model has changed. If we want to change the offset values and some other things, we can do that as well. Now, we're also showing the stack trace over here, and this is a stack from 0 to 50 degrees. We've got our slope and intercept curves over here, and these are all parameters that we can change as well. Now, we have some basics AVO settings up here that we actually put on the toolbar to make it very easy for you to see. We can look at the primary reflection or the shear reflection. We can look at the total contribution, the Shear acoustic impedance, Shear Poisson's reflectivity, or the delta V over B. And then we have different move-out methods that we could apply: ray trace, VMRS, no stretch, none. But as you change these, if I click on that, it just updates it right away, and you can see the impact of that. If I want to look at what's the impact of what portion of this AVO response is contributed by the Shear acoustic impedance, I would see that there. And you see I can look at the Poisson's reflectivity, which is a little more on the far offsets, or I can look at the total contribution. Every time you change it, the title up here shows it as well. Just like the 1D synthetic, our depth time correlation settings are down here. If I had a check shot applied, or if I had shifted. And a few other things. So I've got wavelet control. So right now we have this 25 hertz Richter wavelet at 0 degrees. I can change the phase, and I could change the phase by coming in here and typing a new phase. Or I could I've got little icons here to iterate the phase. And if I click on that, it tells me it's now at 10 degrees. So I'm changing my phase just as simple as that. So I can see the impact that a changing phase would have on my particular model. I'm going to turn these colors back off and go back to my wiggles, showing the wiggles. And we have another thing I want to talk in a little bit is this focus zone right here. We can add multiple ones of these. But what this does is this will give us a few things. We can look at, and if I click on this zone and drag it, we're looking at the RMS down here within that zone. And this is really a little more applicable when you've got, looking in some hydrocarbons and you can see things. So we get into fluid sub, it'll be even better to compare the two side by side. If we want to look at all the controls we have, I can go to Synthetics, AVO Synthetic Controls. So we have quite a few. So we have our initial offset right here at 0 feet. Our offset increments, so we're going at 500 feet. Every 500 feet we drop a trace and a number of traces. And I can change this. I'm going to bump that up to 37 so we go out a little bit further. When we do that now, we see we're going at really far. And beyond about 40 degrees, this particular well really kind of falls apart. We reach the critical angle. That's why we're not getting any response back there. So if I want to change that, I go back to Synthetics, AVO Synthetic Controls, and I'm going to go back to 25 feet on that. Stack and AVO inversion. So our min stack angle, we're at 0 to 50. If I just wanted to look at the more of the far stack, I could say 30 to 50, and I want to look at 3 stack traces. And if I do that, now my stack is from 30 to 50. So I'm looking at the far offsets. And I have to have enough points statistically at 50 degrees to be able to do that. And let's look at a few other controls that we have here. Let's go back and make that 0 to 50 just so that we can have some stuff. Our AVO inversion, we're showing a conventional NIP. This is your slope and intercept. And I have Shuey NIP, Smith-Gidlow, Delta P. I could just show the stack or don't show any, just show the AVO curves. But if I look at my Shuey NIP and PR, okay, these computations change. And when we get into the cross plots that we look at down below, we would see the cross plots of these areas. And how do I do that? I go to View. We have layer cross plots. These are cross plots of parameters on the well log resolution. And boundary cross plots are cross plots in the time resolution over here on the synthetic. So I'm going to hit show that, and it pops them back in here. And again, I can drag this up and down and the like. So I'm looking at the boundary cross plots within this focus zone. And as I move it back and forth, you can see the curves. In this case, I'm looking at B versus NIP, Poisson's reflectivity, NIS versus NIP, so on and so forth. If I want to change those, I go to View, Boundary Crossplot Layout, and here are all the, I could show up to 6 of these going across here, and I have a whole bunch of parameters that I could look on the time domain, looking at any parameter cross-plotted against any other parameter and start to look to see where separation may occur. One other thing I'll point out right here, if I spray this in here real tight, you see this red arrow that shows up here? Well, we've given it a prescribed traces per inch. Right now we're at 8 traces per inch. And we can't fit 8 traces per inch in there. So we have a couple options. 1, we make the screen bigger. 2, we slide this bit over to give this more room. Or if I move that back, anytime I'm not showing all the data, the red arrow comes up. Or I go to AVO controls and I can increase traces per inch, will increase my density. And I can do that until that red arrow goes away. Now I'm looking at everything on the far offset. So anyway, that's a real quick overview of AVO synthetics. There's a whole bunch more we can do with that, and I'm going to have we have another set of videos that just talk about AVO modeling and the things that we can do. But I'm going to close this, and now my model is saved, and I hit save. Now, the other thing to remember, if I go back, synthetics, AVO, In-Situ model, everything we've done is saved, and the view and the like is preserved. So that's a real quick introduction to AVO synthetics. Make sure you watch the series of videos that dive into AVO synthetics a little bit more.